Well, hello and good morning, everybody. It's been a while, I suppose. It's been, I think, like 2 or 3 more weeks since we had one of these. So super excited being back here with you guys. My name is Felipe, Creative Director at MakerBot. And yeah, one of the reasons why we had been a little bit, not so connected is precisely RapidRinse. We'll be talking about the newest material that we introduced just last week. Super excited for it, I suppose. It's just so incredibly easy to use. In a nutshell, soluble supports for ABS, and I have a few samples here. The idea today is that I'll be running a demo of how it dissolves, and then as it dissolves, I'll have, as you can see here, I have my little fish tank here for the demo. As it dissolves, we'll be talking about what it is, how it works, and the benefits for it. But it's, TLDR, it's soluble supports for ABS, and that is water soluble supports for ABS. It's incredibly easy to use. It's way easier than PBA, I would dare to say. Not only that, it's also faster than PBA, and of course PBA cannot work with ABS, which I think many of us really like the properties of ABS as opposed to the more standard PLA and nylon materials. It all depends on the applications, of course, as always. But yeah, I'll get into the nitty-gritty of that. In any case, welcome. I'm just checking with Alejandra in the back end. She's setting up all the questions. If you have any questions right now while we're live, you can post them in the chat section on the right-hand corner, and Alejandra will be forwarding those questions to me. If you have any questions later on, you can of course post them in the comment section down below, and we'll be answering them too. So with that said, hoping that everything is running okay, and let's get started. So couple of parts here. I'm going to actually dissolve 2 of the smaller parts because we don't have that much time. But the point is that in these sort of 15-20 minutes, we'll be able to see how fast this material actually dissolves, right? So I have 3 sets, these 2 gears. So this gear over here, let me see, yeah, I'm on the right camera. This particular gear and shaft, so this is the dissolved version. I already dissolved one of them. I'm going to be dissolving this one. This is the way that it was printed out of the machine. So you see about a 1/4 inch of support, underneath the gear itself. And I'll also be dissolving this 17th tooth gear, which is, similar idea, comes out of the printer. The teeth are hanging outside of the gear right here, as you would expect them to, which makes it, ideal for soluble supports. So let's get started with that. I'm going to be using, to hold them down, on the water, I'm going to be using these pieces of metal. Actually, these are 3D printed parts. I also printed them on my method here, just to hold them down. But let me move the camera so that you guys get like a front and center view of this. So as you can see, this is my little makeshift lab, dissolution lab. Let's get the camera set up here. Here we go. As I said before, this is just plain water. It's warm water in a fish tank. I got the fish tank for you guys actually to sort of be able to dissolve this in real time. And let's get started with both of these parts right now. So first off, here comes the red gear. Should probably get rid of my long sleeves. I'll get a little bit wet. That's okay. Quite a bit. Give me 1 second. I didn't think the shirt through. All set. Here we go. Okay, so sorry, this is in the way. Here's the first gear, and then the second gear will be to the side of it. It's the black one that I showed before, coming into view right now. Here we go. I'll leave them there side by side so that you guys can see how fast it is. Right now it's 11:04 a.m. That reflection underneath the tank is actually just a little bit of water that seeped through while I was filling up the tank. But in any case, I leave them there, submerged while we talk. And feel free to ask any questions, right? As I said, this is a material for ABS. We have the ABS available on black, red, and natural, so any color that you might want. And I have some other parts that I also printed using the same material configuration. These, of course, are way bigger parts. They will take a little bit longer to dissolve. Let's fade here for a second. And I'll leave that camera view there so that you guys can see the process of dissolution. It's going to be fairly fast. I mean, it's not immediate, right? It's not like Alka-Seltzer of sorts, but it should take about 30 minutes to start seeing, you know, some meaningful dissolution there. So this is a massive hinge. It's actually from one of our customers, used in I believe it's one of the Boeing models for the it's a hinge for the overhead bin, right, for the bags and whatnot. So it prints it in a single piece. It has a lot of different attachment points that need to be printed with supports, just because of the way that this part is oriented. There's no way to orient this part where it wouldn't be requiring supports. And this is the way that it prints out. This is how it looks after it's been dissolved. As you can see, you know, side by side, there's a lot of supported areas that need to be supported, just because of the fact that this, you know, it's a fairly complex part. There's no way to orient that part without, you know, or in order to bypass the need for supports. And the way that it comes out after it's been dissolved, not only is it impressive in the, you know, the quality of the part, you know, how clean the part itself is, but also the tolerances and the fact that this hinge is a print in place hinge, right? So it printed out as a single part, and I'm able to just use it, flex it, and play with it, well, or work with it as much as I want right out of the machine once the filament is dissolved. So with that being said, I want to take you guys also to our site. So here's you know, our new and improved site. Of course, we changed the main homepage. We added quite a few pages as well there. Just want to make sure that we have both cameras. Yeah, okay, so there's me, and then there's also the dissolving parts on the top right. In our site, we changed quite a few of our pages, starting with the homepage featuring the RapidRinse. If you guys want to see the video, I would highly recommend that you would. Definitely interesting. We spent some time creating it. And now you can explore our printers in 3 different ways. First off, looking at the series, right? So the Method platform as a whole, which is made out of the printers, the materials, and the software, and the out-of-the-box setups that we offer. So Method X carbon fiber, Method X, and Method. Both Method X and Method X carbon fiber will be able to print with this new ABS soluble support. And today we'll be talking, of course, a lot about the Method X with ABS RapidRinse. Incredible material for ABS, especially because how easy it is for us to use and dissolve with it. It's just hard to convey with, you know, words. That's why we keep having these sort of videos on the time, you know, the time lapses and just showing of how easy it is for it to dissolve. Let me play the video for you guys for a second, because I think, you know, it speaks more than what I can actually do. Would highly recommend that you guys go and check that video there. We have a few time lapses there. All of these parts dissolve in just about 30 minutes, if that, for the main, you know, the bulk of the material. And yes, I said before, this material is compatible with any of the Method X printers. Here's actually the printout of one of the parts that we're dissolving right now. An hour and 30 minutes for it to dissolve most of the supports in those 2 parts. And yeah, also incredibly stable material as well. It definitely is, you know, since it's water soluble, it needs to be kept at isolated from water and high levels of humidity. That's something that you should consider for sure. But all in all, you know, very straightforward to use. The same setup that you would have for dissolving PVA will work here for dissolving now RapidRinse with ABS. You'll have to use the, you know, the reason why you have to use the Method X is because you do have the requirement of printing with 100 degrees Celsius for ABS. As you know, ABS is much more sensitive to higher or needs higher temperature settings in order to print well. And yeah, I think that's mostly it. You have to use, you know, these 2 extruders. These extruders, if you already have them, you can definitely use the same extruders that you would from the Method X. That's the 1XA for the material itself, for the ABSR, and 2XA for the RapidRinse. So it'll run on the same extruder that you would use for the SR30. There's no change there. And you can still use one or the other, right? You can use either SR30 or RapidRinse, depending on the material that you're using. Of course, if you're using ABS, would highly recommend to use the RapidRinse just because of how easy and fast it is to print. We are turning at 6 minutes on the, I'll make a quick break here. So 6 minutes on the dissolution. Let's see if I can wiggle these parts. How are they doing so far? Oops. So you can see how that smoky, you know, sort of, I won't call it goop, just like smoky element that's already like floating around in this part, this other part as well. Right as I removed them, it sort of started going away a little bit. The real change will happen as soon as the outer shell of the supports dissolve, right? It's going to take about, I would say, 20 minutes for that to happen. And then once that's gone, the interior of the supports, and actually you can already see it here. Let's see if I can bring in the macro lens to the shot. Here we go. You can see like right in the, oops, sorry. Need to adjust the lens. Okay. So right on the raft itself, right, the material is already starting to disappear for both parts. Let's bring the black part in as well. You know, of course you're gonna touch it, but it's already kind of like softened up for sure. So we'll leave it there for a few more minutes. Let's remove the lens and readjust the camera. And just need to dry my hand a little bit. Here we go. I got a towel just in case. Okay, so going back to the walkthrough on the material itself, as I was saying, you can use these two extruders for RapidRinse, so 1XA and 2XA. There's of course a lot of additional extruders that you can use with the Method X printer. I'll talk about that in a second as well. All in all, there are 6 extruders available for the Method X. That makes it really flexible in terms of the materials that you can actually use with it. So yeah, highly encourage you to check that out. A quick features overview of the Method X, the tech specs, one particular case study that we did this year with Lockheed Martin. Really nice if you guys want to see how Lockheed Martin Aerospace is actually using the Method X. Would highly encourage you guys to go check it out. And some industry applications on the site as well. Let's talk about the material itself, right? As I said, and I've been saying this for some time today, it's tap water soluble material. There's no additive in the water. There's no need for agitation. Agitation definitely helps, and I actually have, for larger parts, I do have a small, aquarium motor that I can use if I wanted to. In this case, the parts are so small that you don't really require that. You can just leave the parts floating there in water. I definitely would recommend having something to weigh down the parts, but just getting a standard, this I think was like $10 out of Amazon, aquarium pump would definitely help expediting the dissolution process for bigger parts, right? And the way that I do it is I'll just place it here on the tank, but there's really no, technical component to it. It's just the same experience that you would have with PVA. It's what I would say you would need for RapidRinse. I'll just let this run for a second so that you guys can see. Sorry, I'm out of camera, but hopefully you can still hear me out. So very straightforward, the same process or similar to PLA. And even though we say it's as easy as PLA, I would argue that it's even easier, because if you guys have any experience with printing with PLA and PVA, it's definitely straightforward, but it does require a little bit of patience in that PVA does become this goopy solution once it starts dissolving, and it requires quite a bit of time to dissolve. RapidRinse, on the other hand, I think it's way faster, at least in my experience, than PVA. And depending on the part, you can, depending on how big the material is, or how big the part is, especially like something chunky like this one, you're going to be saving a lot of time when using RapidRinse instead of PVA. Second element here, I keep saying that, but I think it's really important to hammer it down, the fact that it's tap water soluble. So SR30, definitely useful for other high temperature polymers, like ASA. You can even use it with nylon carbon fiber, but will require an additive in the water to dissolve. In this case, we're using just plain water, nothing to it. I would recommend also using, the water as it comes hot from your tap. That's also going to help you a little bit. But it doesn't have to be heated up, right? You don't need any additional setup. You don't need a wash tank. You don't need anything but water in order to make this material work. And finally, as we're seeing right now, the filament itself dissolves in just minutes. So you don't have to wait as much as you would with either PVA or SR30 for your parts to be done and ready for you to use. As I mentioned before, there's quite a few available extruders here for the Method X, and Method X of course covers all of the range of materials that we can play with and we have to offer for the Method series. So you have extruder 1 and 2, one for the lower temperature polymers like PLA, tough, nylon, and PTG. Extruder number 2 for PVA, if you still wanted to use PVA for compatible with some of these materials. The standard Method X extruders, which are the 1XA and 2XA, which in turn support the ABS and RapidRinse combination, as well as ASA, PCABS-FR, PCABS, and the SR30 from Stratasys. And finally, kind of our two specialty extruders, which would be the 1C and the Labs extruder. The 1C, it's by far, I would say, our most powerful extruder, without being the experimental one, which is kind of like our sort of open platform version of it. But 1C, it's tailor-made for more aggressive materials such as nylon 12 carbon fiber, nylon 6 carbon fiber, and so on. And Labs, which allows you to print with any third-party filament as long as it's 1.75 millimeters in diameter, right? So we have everything from ABS Kevlar all the way to actually stainless steel, which is what I've got there to support the parts. Let's jump back for a second before I start adding some questions here from you guys in the audience. But let's just jump back to the dissolution. And you can see right now, I want to try and focus those parts. Here we go. But you can see how there's already little holes appearing on the parts, right? Like bubbles of sorts. And we started at 11:04. It's been about 10 minutes, right? And the filament is already starting to dissolve fairly fast. You can see like that one bubble on the right. Let me try to put my finger. There we go, right? That one. So really interesting to see how easy and straightforward the material will dissolve. I'll let it run for a little bit, and in the meantime, I'll start looking at some of your guys' questions just because I don't want to run out of time. Let me go to our questions document. Okay, so will RapidRinse be suitable for ASA, PCABS, and PCABS-FR? No, at the moment RapidRinse is only available as a combination for ABS, right? So you do need to use it with ABS. I think it's kind of like the most widely used material overall. Hopefully, I think we'll be able to expand its application because it's definitely interesting. And I'll leave the parts instead in frame because I think that's definitely more interesting than having me just talking around and the bubbles. While I go through those questions. Second questions, will ABS be sunset and replaced by ABS-R? No, that's not the plan so far, but definitely, something to consider, meaning personally, I would 100% choose ABS and RapidRinse combination rather than ABS and SR30. The material properties are exactly the same. The difference is just the material that they use for support as a support combination. So after interacting with the ABS-R and seeing how easy it is to use, you can see it right now, how it's already bubbling up. Let me recenter this in the camera so that it's a little bit, oops. But you can see like right now, the bubbles there, let's move the camera so that it focuses appropriately. But the bubbles that are starting to form, right? So after having that experience with, come on. Of course, as the water gets a little bit saturated with the ABS-R, it gets a little bit trickier for the camera to focus on it. Hopefully that does the trick. If not, I'll bring in the macro lens. Let's see if it helps a little bit. Maybe to some extent. Yes, no. So I really want you guys to see those bubbles, which I think that they are visible, right? It's like those shiny objects right there. What's better, macro lens, no lens? I'll leave it with the macro lens. See if the camera wants to focus in a little bit. And try myself. So yeah, ABS, regular ABS is not going to be phased out, but I would definitely encourage you guys to seriously try out ABS and RapidRinse combination, just because it's so much faster, efficient, and straightforward than the ABS and SR30, and it still is ABS, right? So really powerful combination. Can I use the extruder model C to print all materials that model 1 and model and 1XA print? That is correct. So all of the materials that are covered by the model 1 and model, and let's go to the side actually, just to make sure that I'm not saying something that's not 100% true, but yeah, the extruder 1C will be able to print all of the materials that are available for the extruder 1A, so PLA, tough, nylon, and PETG. You can see it here. Tough, nylon, PETG, and PLA, plus the materials that are available for the 1XA extruder. So really powerful extruder. However, the one thing that you really want to consider is the fact that the 1C extruder, and the fact that it can print sort of the high temperature polymers, does require the combination with the method X, right? So the three things to consider are printer, printer, extruder, and material. The extruders, if you say buy the 1XA and try to mix it with the regular method, you won't be able to print the high temperature materials, just because the regular method doesn't get as hot as the method X. Method X goes all the way to 110 degrees Celsius in the chamber, which is what you need in order to print ABS. So yes, 1C will cover extruder 1, extruder 1A and extruder 1XA material-wise, but it needs to be combined with the method X printer. And the reason I say that is because it's possible to get the extruder 1C and use it with the regular method printer, right? It will work with the regular method, as I say it here, and a specific number of materials, specifically nylon 12 carbon fiber, nylon 6 carbon fiber, which will be able to be printed out with the 1C in both method and method X. I know it's kind of a tricky one, but if you have any questions, do raise them up, and I'll try to spend more time on explaining those out. Let's go back to our questions document. So, does RapidRinse absorb moisture from air? Yes. So you want to keep that either on the spool packet, right, or in the material base for the printer, right? You want to keep it away from any humidity, because it will definitely damage the material. The material is eager to interact with water, even water that's present in the environment. So that's definitely something for you guys to consider when using this material. You have to keep it dry in the material bag, the dry bag with the mylar bag with the desiccant on it, or inside of the printer in the material base that actually keeps the material also dry and in prime condition. Does RapidRinse stick well to the print bed? Yes. In this case, and I can bring. Am I using the right? Let's go back to the materials here. So for these parts, as you can see, you see how much water is now coming in. You can see like the bubbles coming out. But the way that the rafts for RapidRinse work is we'll start the raft with a layer of ABS, and then on top of that, the RapidRinse will settle, right? That's true also here in this part, and let's see if we can get the same effect. Wow. You see how much, the material is already dissolving and sort of that smoky look of it. But yeah, let the material sit down for a second. So the answer is yes, the RapidRinse sticks to the bed. It usually, for the raft will start with the actual print material that is, ABS instead of, so the sandwich would be ABS, RapidRinse, and then your part, instead of RapidRinse and ABS and then your part, if that makes sense. Let's see, second question. When and where to use water-soluble support? That's a great question, actually. And I have quite a few examples of that, right? The straightforward answer for it is, let's see if I can change my view a little bit here, because I have some other parts, is if you're using parts that are fairly complex, you know, like for example, this propeller, you will need supports. No matter what, you will need supports because, you know, all of these elements are what we call overhangs and need to be supported by something when they are printing. So that's when you start using supports. If you're using supports and you're using ABS, you should definitely consider the soluble supports and the RapidRinse, just because it's going to be way faster to remove and more straightforward to use, especially for more complex parts like this one, right? You could potentially use breakaway supports that are made out of the same material. They tend to be faster to print, but they will be really hard to remove. You know, if I look at this, the way that these two parts come out, right? This is actually the same part side by side, one with supports and one without supports. If you look at this section, there's no way that I would be able to remove the breakaway supports that are needed here with such a complex geometry, right? So you could use breakaway supports for some geometries that are a little bit more straightforward. Maybe even something like this propeller could potentially use breakaway supports, but breakaway supports tend to be a little bit harder to remove, especially for very intricate areas in your part, right? If you have any sort of perpendicular holes like what's happening here, if you have any sort of intricate crevices, it's going to be hard. In this case, you know, the top view of the propeller is fairly straightforward. You can see through it. So you wouldn't really need supports here. But I would say that as the part becomes more and more complex, the use of breakaway supports becomes not ideal, to say the least, right? You really want to consider how complex your part is and then balance things out. It's going to require a little bit more time and maybe some of the post-processing, like what's happening here with the added step of dissolving the material, but it will definitely yield, you know, super clean results and ready to use parts that can be really complex and benefit the most out of 3D printing. Let's see, help, my material absorbed too much moisture to successfully print. Any advice? That's a tricky one. So we do have an annealing feature in the MakerBot method, but a few things to consider. You could put your material in a bucket, or in a sealed bag with just desiccant on it, like a bunch of desiccant for a few days, and see if that helps. There's also an annealing feature on the method printers that actually will heat up the chamber to, I think, about 40 degrees Celsius for about 8 hours, and it essentially cooks away any of the moisture that might be in your filament. There's a limit, of course, right? If your filament was exposed to extreme humidity, let's say 100% humidity out for a couple of days, it might be hard, near to impossible to reset it. But if it was a little bit and you're just having a few issues with clogging and the like, you can definitely run the annealing feature. It's under settings, settings and then advanced, I believe, where you can actually find that annealing feature on the method. And then, of course, 100% recommend having that filament inside of a dry sealed bag with enough desiccant on it to absorb any moisture. So with that, I'm going to see if we have any more questions, and we'll do a final twist of these parts, trying to see if we can get rid of that. Yeah, it's actually the bottom raft is already kind of peeling away, and you can see it here. That, let me bring the macro lens. I think that's going to explain it better. So you can see how much of the material has already been dissolved, right? So I'm left now with essentially the connection points to the teeth. Most of it, it's actually already dissolved. Trying to keep this in frame. But yeah, it's been about 20 minutes. Here we go. And the material is already kind of peeled off. That's incredibly impressive. I don't know the experience that you guys might have. For me, at least, with PVA, this wouldn't be like, PVA would be just starting to dissolve, you know, after 10-20 minutes. Let's see the other part. It's kind of tricky to have, like, to hold them down and at the same time show them to you guys. But similar story, right? The raft, oops, sorry, let me bring it down. Here we go. The raft is definitely coming off now in this part, and the tooth themselves are already losing quite a bit of the supports. It depends on how dense the supports are printed at, for sure, and there are certain settings that can alter that, but you can see how many of these teeth actually don't have any support left underneath them, right? Let's see, there we go, that's a better view. If I remove the raft, wow, look at that. It's almost coming completely off. I'm sorry I'm doing it with just one hand, so it's also a little bit trickier underwater. I'm not trying to brag or anything, but look at, wow. Look at how clean the part is already, and how easy it is for me to just remove the supports now. That's awesome. I wasn't expecting that. Look at that. It almost all came out. Now, this internal section is actually a mirror of this top view. So it has a lot of material capped inside of those two rails. But yeah, most of the supports are now entirely gone in this part. I'll leave it there for you guys to watch. And yeah, look at that. All of the supports are, you know, super smooth and out, but they came loose so cleanly. And in this part, let's see if we can do the same thing. I don't know why it's a little bit smaller, but it's not coming out as easily. And I know that we're running a little bit low on time. Oh, this guy wants to appear in the show more than it needs to. Here we go. Sorry, bringing it down. Wow. Yeah. So also, like, most of it is already gone, right? It was just like the connecting elements, but you can see how most of the overhangs are completely freed from that part, and I'm just left with essentially the sort of floors and, oh, get out of the way, the floors and the roofs of the support material itself. I'll leave it there and jump for a final round of questions, because I know that we're, oops, a little bit out of time. I'm sorry, I was a little bit too surprised by that result. Let me dry up my hand before jumping into the and we'll have that raft floating around casually as we do the final round of questions. Let's see now. Do you have a filtering process to collect the dissolved material before putting it down the drain? No, I don't. And actually, there's a whole sheet on how to dispose of the material. But you can, the TLDR is that you can essentially just let it run down the drain, and this material is completely safe to be drained out, right? It doesn't have any additional chemical components like you would with, for example, SR30, which I believe needs an additional process in some facilities and depending on where you live. But yeah, no, it's essentially just letting it down the drain, and that's it. So with that, I thank you guys again so much. You know, we are going to be doing an extended version of it, I think tomorrow on a proper webinar. But if you have any questions, do send them out in the comment section down below. Let me know what your thoughts are. If you have any more doubts on how the compatibility works with this material, really excited for it. We definitely spent quite a bit of time testing the material out and making sure that it works for you guys. And you know, all in all, I'm definitely impressed by the results. So yeah, as always, thank you guys for joining so much. My name is Felipe. Do reach out, hello@MakerBot, if you have any more questions. Felipe@MakerBot as well. And yeah, we'll be seeing you guys next time. Thanks a lot. Bye.